Hello everyone, see you again. Let's continue with this combinational circuits on the chapter 5.1. So we continue with the encoder. For the previous videos, which is encoder, but for this video, we will learn about encoder. So this is the ICs of the encoder. If you look at the symbol here, it's not much different compared to the decoder. It has n outputs and 2 power of n inputs. The number of inputs more compared to the outputs. It is vice versa compared to the decoder. The encoder is a device that generates a unique binary code in response to the activation of each individual input. The example of binary encoder, 4 to 2 binary encoder. So you can spot the difference between the decoder, the difference of the input and output. So this is the example of the 4 to 2 binary decoder. X1, X2, and X3. If you have the input 0, 0, 0, then output is 0, 0. If you have input 1, 0, 0, 1, the output is 0, 1. If you have your input is 0, 1, 0, so your output is 1, 0. And 1, 0, 0, your output is 1, 1, 1. Is 1, 1. In order to understand the output of the binary encoder, you can see the input. If the input is 0, then the output is 0. Input is 1, 1. This is 2, 2. And if the output is 1, 0, 0, the input is 1, 0, 0, and the output is 1, 1. This is 8 to 3 encoder. You have 1, 0, I0 until I7 input, and the output is 3. This is 8 to 3 encoder. So if you understand the working principle of encoder, then easily for you to understand when you look at the truth table of the encoder. Please remember that in order to get the output of encoder, you have to see what is the active input of the encoder. So for this example, if you look at the first row here, the active input is 1 at the input I0. So 0, so the output is 0, 0, 0. Logic 1 here at I1, so the output 0, 0, 1. Okay, it depends on the number of the input, numbering of the input. This is 1, 0, 0. 0, 1, 0. This is 1, 0, 0, 4. Sorry, active I3, so this is 1, 1. This is 7, so 7 is 1, 1, 1. So you have to remember or to understand the working principle or the concept of the 8 to 3 encoder. Okay. So this is the equation of the output from the encoder, where you can get it from the truth table. So from here, you can construct the circuit or the combinational logic circuit, logic gates of the encoder. This is one of the type of encoder, which is priority encoder, because when there is one, there is more input active, the higher order input has priority over the lower order input. If you look at here, this is the normal encoder, only one active input at one time. One, you see, 0, 0, 0, you get only one. But if there is two input or more active, two input active at one time, so this is, we call it priority encoder. So what is the output? The output may follow the priority over the lower order input. So this is the example of priority encoder. So if you have two, for example, these two active input, so it will follow the higher order, which is I1. So the output active is 0, 1. 0, 1. Sorry. If you have the okay, if you have this one, 1 at the I2, this is 1, 0, and I3 is 1, 1.